In this video, we're going to start practicing with how to use automated testing in Django. And here we will be working with a simple test case for just a basic unit test script. And so if you created your chapter applications using the Visual Studio IDE, you'll notice that in every file, in every app that you created, that it automatically generated a tests.py file for you. If this file does not exist, go ahead and create one in your Chapter 9 app at this time. And so it's in this file that we'll be creating our simple test cases. I'm going to open up Chapter 8 real quick and show you that using the Visual Studio IDE in every app, the simple test case was automatically created and generated for you. If you're creating them through the command line, I don't think this is created for you, but the tests.py file might be created for you. I'm going to close this out again. So it's in this file that you can comment that out. We're not going to look at it, and we're not going to want that to appear in our results. We don't have to worry about the previous chapters because there is a trick to that, and I will show you the trick in a moment. Let's first make sure that we have our first test class created. And so it's in our Chapter 9 tests.py file that we do want to import this simple test case from the Django.test library. And a simple test case is just what it means. We are using it only to test for like true-false statements, simple logic statements like addition, subtraction, multiplication. It doesn't go deep into testing models or connecting to your database. If that is what you need to do, then you would use the test case class for that. And then the client and the request factory, these are used for testing views and testing API endpoints. But also, if you needed to get into testing API endpoints, that's where the Django REST framework package provides its own set of test classes as well. So for our first exercise, for the basic unit test script section within this chapter, we'll just be creating this testing calibrator class using that simple test case. In here we're demonstrating how to set up your test and how to tear down your test. This is stuff in the setup definition. It's used to prepare your environment in any way, create objects that could be used among all of the test cases, which are these test methods within this class, instead of having to rewrite it over and over again for each of these test classes, test cases. The teardown is not used very often, but it's depicted here to show you how you would access it if you did need to perform any kind of tasks after you are done with your tests. And keep in mind that Django does create its own test database, and it tears down the test database after this test class has finished all of its methods. So that's one reason why the teardown isn't used very often, because it already takes care of a lot of those teardown tasks for you. So here we're we're calling it testing calibrator just to see if we're going to create two tests, and we're going to make one of them pass on purpose, and we're going to make one of them fail on purpose. And so it's our calibrator to see if the one that should pass does passes, and the one that should fail does fails. And it's also used to demonstrate to us how we actually perform these tests, and to give us an idea of what the output is actually telling us. And so for that, we're going to go to our command line where we have our project running. So make sure you do have your virtual environment activated. I previously had performed my Python manage.py run server, so I'm just going to break out of that because we do need to access the command line. And so here we can run, we're going to run two commands. The first one is just the Python manage.py test command, and what this is going to do is it's going to execute every test case. That's these test methods that you see here that are found in every app in every tests.py file. So not just the chapter 9, but everyone that exists. And so here it found 10 different tests, and out of all of those 10, only one of them failed. The these dots, each of these dots represent a test that passed, and the capital F represents a test that failed. Sometimes you'll see a capital letter E depicted here, and that means that that particular test had an error of some kind, which is different than a failure. There's a couple of things to keep in mind when looking at the output of these tests. So for each of the tests that either failed or errored, it's going to tell you the name of that test method. This particular one is called test fail. And so here we can actually look in our chapter 9 tests.py. On line 49 is actually where this is happening, and see that this assert false, when true is passed into it, does not pass, and so it tells us true does not equal false. Now the alternative is we can run this command here, the Python manage.py test, and then using Python dot notation specify the path to where your app is located. In this particular instance, it's the becoming a Django Dev folder and the chapter 9 folder, which is the chapter 9 app. And that's if you look at our settings.py file, also the same Python dot notation value that you entered into your installed apps. And so here we're telling Django that we only want to run the chapter 9 tests and none of the rest. So now if I run this, what we see are only 2 tests that were run. And that's because out of this entire file, I've got most of the other test exercises commented out at this time. And so it's only looking at testing calibrator class. And out of that, 2 of these are management methods. So those aren't actually tests that are being performed. Any test method that you do have within here that you want to run, they do need to be named with lowercase test underscore in front of every single one of them. in order for Django to know that those are tests being executed. And so you can name it anything you want after that. So here I'm naming it pass and fail. And so that's where it sees that there's only 2 of these within this class, and it only runs those 2. And so that concludes how to write a basic unit test using the simple test case, and how to perform tests, and how to target a specific app if you wanted to. You could even get more granular, and you could specify just this class as well if you wanted to. In this video, we're going to expand on our test cases, and we're going to practice testing Django models. And so back in our chapter 9 tests.py file, let's go ahead and just comment out the testing calibrator class that we created. That way we're only looking at what we want to look at in this particular exercise. In your chapter 3 models.py file, make sure you at least have this value present in your make choices list. You could just copy this entire list over into your project, but at least make sure you have the number 8 and the string representation here. And then back in our chapter 9 tests.py file, we'll be using the test case from the Django test library this time, instead of what we used in the last video, which was the simple test case. We'll also be using the money class from the DjMoney.money library, and also make sure that you are importing all of your chapter 3.models. And then here we're going to create a new class called model_unit test case, and we're going to use the test case class for this one. Here we're going to define our setup method and one test case called test full vehicle name. And so what we're actually testing for, so if we go to the models, our chapter 3 models, where we wrote our vehicle class, we did create a full vehicle name method within that model class. And so what we want to test is whether or not we're getting the expected value in return. So we're testing to make sure that it's formatting the full vehicle name as it should in this particular test case. So there's a lot more that you could be testing for, but some of that is taking place right here, where we're actually creating objects. And so we're not testing for changing an object, we're not testing for deleting an object, but this does create the object in your test database and allows us to actually perform a lookup or a read operation to retrieve that object from the database. So we look at our setup for this particular VIN. We'll see line 68 right here is where we're actually creating the vehicle object. this and for our seller, this create user is a method provided with the default user model provided by the Django auth library. Since we're extending the Django user model as our chapter 3 seller model, that's why we can use and access this create user method. And this is important because what this will actually do is hash the password that you're creating for it. It's not going to hash it as a raw, or it's not going to save it as a raw password. So that is pretty important if you're getting into this and you need to really mimic a real user. But for the rest of these, we're just going to use the create method. And it's where we're defining these specific values that we want to look up. And so it's here that actually line 79 is where we're assigning that vehicle to the seller. And in order to test this particular method, this is kind of redundant and not necessarily needed, but it's here to demonstrate how to link related objects. And in this particular instance, for the seller, it's related many-to-many vehicles. And so that's where we're using the set method to set that vehicle as a related object. And then for the vehicle itself is where we're linking the model object that we created and the engine object that we created in the 2 lines before. So back to chapter 3, when we were doing this using the Django shell, this is the exact same approach, the exact same concept, except this we're actually doing within the setup method within a tests.py file. We're not going through all the mumbo jumbo to activate the Django shell right here using the Python manage.py shell command. So back to the actual testful vehicle name. Line 87 is where the actual magic happens, and what we're doing is we're checking to see if this first parameter equals this second parameter. And so this is always going to return the string representation. Well, actually, if you just did vehicle 1, it would return the string representation of that object. But since we're accessing this property, this full vehicle name method of that object, it's going to equal whatever this returns. And so this is returning a string. And so because it's returning a string, we're going to use our comparative value as a string. So if it was a number, we would use a number such as an integer, or if it was a float, we would use a float, a number with decimal places. If it was an address, we'd put an address object in there, etc. And so here we'll go ahead and we'll run this. So for this, I'm going to use, or continue to use, the chapter 9 test command instead of running every test within our project, so that we can only see what we're working on in this particular chapter. And since I commented out the first class, we're only going to get one test and that's because there's only one test method in this model unit test case class. And it succeeded. The dot also represents that it succeeded. And what that means is that vehicle 1 full vehicle name actually equals this value. Another way we could figure that out is I'm going to add a print statement right here within the code. And I'm going to look for that print statement when I run this test command one more time. Here we could see that it did print out this value, which does equal the value that we're looking for here. Now, if we wanted to check to see if this is failing, I'm going to use this example where I just added a bunch of gibberish to the end. So we could see that it does not equal the value that we're expecting. That's because our database does not have this gibberish in anywhere. So going back to the example that does work, if we wanted to do some extra practice, we're going to demonstrate how objects are being stored in the database. And so we're going to look up in this second set of assertions, we're going to look up vehicle by ID number 1. And so we're going to test this first without a fixture. And we're going to see that when we're creating a vehicle right here, and since Django automatically spins up a test database for us, there's no data found in that database. So this vehicle, since it's the only vehicle we're creating, should be created with a primary key or an ID of the number 1. And so here we're going to look it up by the VIN number, which we should always get in return no matter what the ID is. But here we're going to look up the ID equals 1. And I'm going to check to see if it equals this value. And this should not, because I'm going to add a print statement here as well to tell me what vehicle number 2 is. So let me run this again. And we can see that it failed. And if we look at what was printed out, a Jeep Grand Cherokee was the value. So we're checking to see if Jeep Grand Cherokee equals Chevy Blazer. And it's telling us that it does not. And the reason why is because this value was created at number 1. Now I'm expecting that to fail on purpose because what I'm actually looking up here is the value of the first vehicle in our chapter 3 fixture. So here we've got make 3, vehicle model 3, and engine 2. we know that in our make choices, the value of 3 is a Chevy, and the value of a Jeep is an 8. And so you could look up the value of the rest of these by looking up what is vehicle model at ID number 3, which is a Blazer LT. And you can look up what is an engine with an ID of 2. That's the 3.9 that you see here. And so that's where I'm compiling these values, because I'm really checking for the first vehicle in the database. So if I load a fixture now, we'll see that there are actually 7 vehicles within this fixture. So using this option outside of any of the methods within your test class called fixtures, you can give it a list of fixtures that you want to load, and that will be loaded whenever this setup method is performed. You don't have to write anything in here, it's just automatically going to load the fixture into the database when it's created for you. So now that I did that, when this vehicle is created, it should print, or it should be created at ID number 8. And so now when I run this, this should pass successfully. And I added a print statement here to look up the ID of when this vehicle is created. So now I'm going to run this again. And this time it did succeed. Here we see that the value 8 was printed. That is actually the ID. So that is as expected. It's no longer ID number 1. And vehicle 2 equals the Chevy Blazer now. Again, I'm just going to comment this line out. So now it does not have the fixture, and we'll show the failure one more time. And so it failed. It's telling us that these do not exist. This time the number is 1. So you could see that it's working as expected. And that is how you test Django models. Very limited and simplistic Django model. Your test cases will likely become more complex and with many more test cases within those classes. In this video, we're going to start testing method-based views. And so go ahead and make sure your project is running. And in your chapter 9 tests.py file, go ahead and comment out the first 2 classes that we worked with. And this time just leave uncommented the your request test case, which we'll be working with in this video. And this is going to use a test case class because we are going to actually be connecting with some of our URLs or paths within our project. We are going to use the setup method and it will consist of one test method called test method based. And what we are actually testing for, and the reason why I said to make sure your project is running, so that we can navigate to the My Year path. And this is an example that we worked with earlier in Chapter 4. Yes, Chapter 4. And so if we go to that, we'll see that we do get the year page. And what we're testing for is to make sure that this year value is numeric value. It's not going to be letters. And as a numeric value, it is going to be greater than the year, not greater than or equal to the year 1900. And so we'll see that both of those we got page not found. And so the purpose of this test is to make sure that that is consistent. So in our setup method, we're going to create a factory. This request factory that comes from the Django test library. This will automatically generate data if that data was needed. And here it's going to generate mock request data. And then we're also going to be working with an anonymous user. So that's where this anonymous user class comes in. We're going to set that as the request .user. And that's coming from the Django contrib auth models library. And so it's pretty simple. We'll create a request object first, and that's using self.factory, and then we'll get the path that we're actually looking up, and that is this path here, 2022, not 12. And then that's where we then set the request.user to equal the anonymous user, and our response will equal the practice year view method, which we're importing from our chapter 4 views library. So this is the actual method that we wrote. And if we go back to our chapter 4 views.py file and take a look at that method here, we'll see that this is where it's performing its actual operation on checking to see if the year is greater than or equal to 1900. And we pass in the request and the year value that we want for this method. So we're mimicking how this is actually being used. And then we're going to use an assert equal operation, and we're going to make sure that the response status code does equal 200, which is the successful response that we're hoping to get in return. So now if we turn off our project from running at this time and then execute our chapter 9 test command, we'll see for that the path of the year 2022, we do get a successful pass. So now if I mimic this to be a year that is not 2022, that's significantly less than that, such as the number 12. And I rerun our chapter 9 test command. Then what we get this time is in fact an error and not a failure. And so looking up where we see the dots, this is where we actually see the letter E for the first time. And then it tells us the name of the method that it errored out in, and then anything that you put in your 3 quotations on a single line will appear as detail about what that method or that test is doing. I noticed that if you break this down on multiple lines, that it will only tell you the first line. And then, so looking at the traceback of what actually happened here, we'll see that at the very end, and our chapter 4 views.py, line 43 is where the error is actually taking place. So line 43, we see that year was not found, and that's because this is the else of is year greater than the year 1900. And so if not, well, we want to actually make a 404 response, which is not a 200 status code. So then it will fail. And in chapter 9 test.py, line 121, we could see that that is where the method that is being failed is being executed. So it's a pretty good tool on how to trace back the information of the problem that occurred. And that is how you test method-based views. And this is just a very, very simple example. Yours might become far more detailed and far more complicated than this. In this video, we'll be testing class-based views next. And so in our chapter 9 tests.py file, go ahead and comment out every of the other classes that we used in other videos. And in this one, we'll be working with this vehicle underscore request test case class. This one's also going to use a test case class, and we're also going to use our chapter 3 data fixture. And in this one, we're still going to use a setup method, and it's also going to consist of only one test case called test underscore class based, as in the class based view that we're testing. This one in particular is going to be the vehicle view class that we're importing from our chapter 4 views.py file. And so going and looking at that, we can see that here all we're doing is trying to attempt to look up a vehicle by the ID that is passed into this get method as a URL parameter, and that is again the purpose for importing this particular path from chapter 4. And so before I explain more about this method, this test method, let's go ahead and run our project. And let's just navigate to this localhost vehicle and number 1 path. And in my local database, I've already got the chapter 3 data fixture preloaded. So it's going to have at least 7 different vehicles within my database. And so here, if we were to actually look up a vehicle ID that does not exist, then we would get a page not found. And so that's essentially what we're going to test for within this method. And it's going to be written pretty similar to how we did it in the previous exercise when we tested for method-based views. We're going to create a request object using our self.factory that we created in our setup method. That again uses this request factory class provided by the Django test library. And we're specifying the path that we want to look up. So this one in particular is the first vehicle ID within our database. And again, we're going to use the anonymous user class to set as the request.user. And that is being imported from the Django contrib auth models library. And our response will equal the vehicle view class that we imported from chapter 4 as view. So pretty similar to how we write a URL pattern. And we're going to pass in the request that we created up here and the numeric ID. And that is because in our get definition, we are passing in 2 optional parameters. They're actually required parameters. And then we check again to see if the response status code equals 200. So if we got a 404 not found, that obviously would not equal 200. So going back to your command line, make sure that your virtual environment is activated and run the chapter 9 test command. And here we could see that it did execute 1 test successfully. So now let's use the value of 99 that we just tested within our browser that we know for a fact does not exist. And just to make sure that this is working. And so we can see that it actually failed. And this time it errored instead of an actual failure. And that is similar to the previous exercise where in our chapter 4 views.py file on line 76, seen here, we are raising a 404 response because it did not actually find a vehicle within the database with the ID of number 99. And so that is how you test a class-based view. And in a real-world scenario, your test class would possibly have many more test methods and a lot more detail to test for as well. In this video, we're going to test authenticated view requests using the client class provided by Django. And so for this example, we're going to this is where we're actually going to use this client class imported from the Django test library, and we'll still be using a test case. And we will need the seller model class from our chapter 3 models.py file. And here, go ahead and comment out every other test class that we used in other videos, and create the seller underscore client test case class. And that uses the test case class that we imported from Django. In this example, we are going to import the chapter 3 fixture. And that is what actually contains the seller object that we're going to be working with here. And so essentially what we are going to be looking for is, in the previous chapter, in chapter 8, we created a custom seller API endpoint where we enter in the ID that we want to look up, and it will return to us pre-formatted HTML. And if we go to our chapter 8, our chapter 8 urls.py file, we could see right here on line 55 is where we created that endpoint, and that links to the getSeller HTML view class, which came from the chapter 8 views.py file. And so here we can see that it does a simple lookup with the ID that is provided in the URL to search for the seller within the database. So that is why we need to make sure the chapter 3 fixture is preloaded in this test example. And so if we run our project, which it's doing right now, and navigate to this chapter 8 seller, I just opened a bunch of them, we could see the pre-formatted HTML that it returns to us. And if we enter in a value that doesn't exist, we can see that we do get a 404 response. And so within this class, we are using a setup method and just one test case, and that's the test underscore get method that you see here. Within our setup, we are going to set the current user to equal the first seller within that chapter 3 fixture, and it does that by performing a get operation. And then we're using a client, that client class, to perform actually logging into the system. So this has nothing to do with if you went to /admin and were logged in or logged out. That wouldn't matter in this particular instance because it's doing it within its own test environment. So here we're going to mimic actually logging in, and this is where we use the username provided by the first seller object and we're entering in the password manually. It might be wise to store this in an environment variable instead of hard coding it within your file as is done here. And then within our test case itself, we're creating a response object using self.client.get, and we're specifying the URL that we want to test. And then we want to make sure that we're getting a 200 response in return. And then here we're going to check to see if the seller name, which is the business name field, not the actual first and last name, if it equals what we're expecting it to equal. And here we're actually looking for this value right here. And so if you go ahead and stop your project from running and execute the Chapter 9 test command, it's possible that you will see a conflict with using the Django debug toolbar. The flow of the chapter is that if you're just working on this video now, you haven't actually installed the Django debug toolbar, but I, as the writer, have already installed that. And if you watched the first video provided with this chapter, you may have already installed that. So one workaround is to set your debug to false, and that could be done in the environment variable as well. And what I did was I took the debug toolbar app out of this variable here, and I'm saying if debug is true, then I want to include this debug toolbar app, which then gets compiled into the installed apps. And additionally, I did the same to the debug toolbar middleware. I took it out of the first value of this middleware list, and if debug is turned on, I am setting it as the first value within that list. So then if debug is false, we can run our test without getting this Django debug toolbar issue. And that's only an issue when you're using the client class and possibly a couple of other classes, but it's not an issue with all of the Django test framework. And usually you want to have the Django debug toolbar turned on in a debug environment, and then run your tests when debug is false. But that's obviously not always the case, and so just keep that in mind, that you would want to turn this off if it is a conflict. And so here we can see that this time we actually were able to perform our test, and not only that, our test did succeed, so it passed its test. So then if we tried looking up something that a seller that did not exist in our database, And we know that because we only have one seller that we created in this fixture, and that's a primary key of 1 and definitely not 10. So if we looked up ID number 10 and ran our test, we would see that it did error out, and that happened on line 179. And that's because none type has no attribute name, so it did not find anything in return. And the reason why that is because if a seller isn't actually found within the class that we wrote, all we're doing is we're saying seller equals none, and we're passing seller equals none into the context. And then if we go and we look at our chapter 8 details seller.html file, we'll see that if seller equals none, we're just returning a different set of, or a different block of HTML instead of returning a 404 response. So either way, whether or not the seller was found, it's always going to produce a 200 response. So this is going to pass. We set that to a value that does exist and look up an incorrect name, we should error out on the exact same issue here. And again, we did. And this time it just has an incorrect value that it's comparing. The previous time it had an issue comparing a none, no object, let alone an incorrect value. But if we wanted to test whether or not we're successfully logging in, here we could try giving it an incorrect password. And we know that the password provided with the code in this book is this password right here. So if I give it an incorrect value and run this, we'll see that instead of an error, we got a failure. And that's because now our response status assertion on line 175 is returning to us a 401. And now 401 is unauthorized, or you do not have permission to access this page, whereas a 404 is this page is not found. So we do not have permission, and that's because we provided an incorrect password during our setup method. So any test, if we had like 10 or 15 different test cases within this class, and they all relied on the same client login system, then all of them would potentially fail and return a 401. And so that concludes how to use the client class to perform authenticated view request tests. In this video, we'll be testing API endpoints within our project, specifically those that are created with a router from the Django REST framework package, or those view classes that you've created using the API view class, also provided by the Django REST framework. And so within your chapter 9 tests.py file, go ahead and comment out every other test case and class that we're not using, just so that we could focus on the create an object from an API endpoint test. And for this, we'll be creating a new class called engine_API test case, and that uses the API test case class that comes from the REST framework.test library, and that again is from the REST framework package that we've installed. And so writing this class is going to be pretty similar to how we wrote the last class when we worked on testing authenticated view requests. So it's going to be pretty similar to the seller client test case that you see here, in that we are going to import the chapter 3 fixtures and use that within this test environment. It will include a setup definition, and we'll work with just one test case at this time called test post, so that we can create the object that so that we could create the engine object that we would like. So here we define our user and our client using the API client class. That also comes from the REST framework.test library. And we'll be using the API client just as we did with the client class. That came from the Django test library. And then we log in the same exact way, providing the username that we just looked up for the first seller, and that's provided in the chapter 3 fixture. So we're looking up that username and then the password. And so here we just use the unhashed version of the password to log in. Again, it would not be good practice to keep this within a file. You might want to store those in an environment file somewhere. And then for the post test, we're going to use this response code here, where we're actually sending the name of the engine that we would like to create. And so we can see that we really only have one field that we have to worry about when we're creating the engine. And the format of the payload will be in JSON format. So here we're checking for two things. We're going to check to see if the response status code equals a successful creation, and that is a 201 code versus the 200 that we've been looking up. So 201 indicates that the object was created and it was successful. And then here we are checking to see if the information that was returned to us has the same value for the name field that we provided when we wanted to create that object. And so what gets returned to us is the object that was created. So then if we go to our terminal and make sure that you have activated your virtual environment, we can go ahead and run our chapter 9 test command. And so we'll see that this actually succeeded. And if we wanted to actually check to make sure that that is true, say we didn't know what response data actually was. Here I'm going to perform a query, and then I'm going to see if the name value of the object that we looked up actually contains the value that we used to create that object. So here I'm looking up ID, or primary key, of number 3, and if we look at the fixture that we are loading into this environment, we only have 2 engines that are created. And we can see here only 2 of them are highlighted. And we have a primary key of 1 and 2. So naturally, Django will want to create that at ID number 3. Because we know that this is a fresh new environment that gets created every time the tests are executed, rather than, I should say, when the setup method is executed. And so let's go ahead and run this now. We'll see that it actually did pass. So we know that the object that we looked up and the object that got returned to us are in fact the same object. And another way that we know that is because the names that are provided here are nothing like the name that we provided in the test. And then also, to do the same exercise in understanding how the login function is working, let's go ahead and give it an incorrect password and just see what happens. So now we know that the assertion is incorrect. What got returned to us was a 401, and we're looking for a 201 right here on line 208. And that indicates that the password that we tried to use, or the username or the password, any of those combinations were incorrect, and 401 is unauthorized. Thou shall not pass. And so that concludes how to test for creating an object with or on an API endpoint within your project. In this video, we're going to continue to work with testing API endpoints, except in this one we're going to update an object that already exists within the database, whereas in the previous video we created a new object and then tested that. And so for this one, let's go ahead and comment out the test post method that we created in the last video, just so that we could focus on the tests that we're working with now. And again, we're going to continue to work with the same engine API test case class that we wrote. So our setup method will remain the same. Make sure you're using the correct password and not the incorrect password exercise. And we will need to continue to use the chapter 3 fixture. So for this one, we're going to create a new method called test_put. And it's going to act in pretty much the same way, except one difference is that our self.client.post method is now a put method for the response object. We continue to set a destination URL, this time instead of just /engines, we're doing /engines and then the ID of the object that we wish to look up. So in this particular instance, we're going to look up the first engine object within our Chapter 3 fixture, and that's this object that you see here. So if anything, this is the name that we would expect unless we've changed that name. And here is the payload, which is the information that we wish to update. And then our format, which is still in JSON format. So here we also check to see if the response status code is value that we are expecting it to be. In this case, 200 would be a successful put update. And then we're also checking to see if the data that gets returned to us, the object that was updated, now contains the value for the name field equal to the value that we've expected it to change to. And so now let's go ahead and open up your terminal, make sure your virtual environment is activated. And here we can execute the Chapter 9 test command. So we'll see that this one actually succeeded. That means that it was successfully changed. We're getting a 200 response, and the value that was in the name field is actually updated. Another way we could verify this is by performing a lookup. And here we'll just do a get operation, looking up an engine with an ID of number 1. And so here we look up to see if new engine name field equals the value that we changed it to on line 223. So we'll go ahead and execute that. And we'll see that it was successful. A couple other ways we could try that is if we check for a 201, which is the value that we were looking for in the previous exercise. And we'll see that it is behaving in the way that we expect it to. So let's change that back to what it should be. And also, if we wanted to enter an incorrect value here, meaning an object that doesn't exist, we know that since we're loading the Chapter 3 data fixture, and since we know how the Django test environments work, only these two objects will exist within the database when this test is performed. So if we try to look up an ID of number 99 that we know for a fact doesn't exist, then this is the results that we would expect. 404, which is a page not found error. And that concludes how to test for updating an object on a REST API endpoint. In this video, we'll be preparing our project for the Chapter 9 exercises and also install the Django debug toolbar. And to begin, let's make sure in our main settings.py file that we include our Chapter 9 app, and also make sure that you've created a Chapter 9 app within your project and copied over any of the necessary files from previous chapters. And you can continue to leave the previous chapters turned on, just as I have here, because also in this one we will be accessing many of the Chapter 8 URLs. And so then in our main urls.py file of our project, go ahead and comment out the previous chapter's URL patterns. And in this chapter, we'll be using this set of URL patterns. where we're including the chapter 9 URLs and then the chapter 8 URLs. And we want chapter 9 to come before chapter 8 because it's going to take precedence in this order. And so then in your chapter 9 URLs.py file, what we're going to do is define two, or actually three of, just two of the paths that we created in chapter 4. This is our home page that we've been creating for every chapter. But to show you, if we look at our chapter 4 URLs.py file, we could see that we worked with many different variations of the same URL throughout that chapter. And so instead of trying to explain in a lengthy way which one of these we want to use, instead I'm providing you which ones to use. And then if we look at our chapter 8 URLs.py file that we did load, all we are doing is just, we've got one variation of them, so it's not going to be very confusing if we just include this entire set of URL patterns. And these two are going to get overwritten by anything that's found in the chapter 9. So obviously this one will take over. And then next we're going to make sure that the Django debug toolbar is installed. And so this requires several settings in our main settings.py file. Do make sure that these two apps are installed because they will be needed for the chapter 8 URLs that we're going to test. But for the Django debug toolbar, you will need this application installed in your installed apps variable. And that also requires, in our requirements.txt file, requires us installing this Django debug toolbar package. And if you install it through the requirements.txt file, that's fine. You can install it manually if you run this pip install command, pip install Django debug toolbar. However, I've already got it installed, so I'm just going to run my server. So then going back to our settings.py file, we'll scroll down to our middleware settings. And here we're going to install this this debug toolbar middleware. And we want to make sure that this is actually at the very top of this list, or else we're going to get several different kinds of conflicts and errors. So a good way to avoid that is to just make sure it's at the top. And then also some of these settings are already going to be defined within your project. But if for some reason you're working on a different project or you got handed a project through a repository somewhere and you haven't been on it since the project was first created and some of these settings don't exist, you will need this internal IP, and Also, in our installed apps, we will need to enable this Django contrib static files. So again, if they're not turned on, do make sure that they are if you wish to use this package. Another requirement is defining a static URL. That could, this could either be static or static files, depending on what your project is set to. In our case, it's actually static files. And then also we want to, we're going to go to our main urls.py file. And down here, after we've written our URL patterns, we will be defining a conditional statement where we're checking to see if our settings.debug value is true. And again, we're importing our settings from the Django conf library. And it's in here that we're going to actually add our import debug toolbar pattern, or our debug toolbar library. And then we do need to define this debug URL pattern where we are including the URLs that are provided by that, that package. And then in order to work with Heroku, so this should work locally as it is, but if you want that Django debug toolbar to appear on a development or staging environment, again, you don't ever want this to appear on a production environment, but since we're using Heroku with the white noise package, it is needed to define this debug toolbar config, and inside of it we're going to set the show toolbar callback to equal this callback, and I'm pretty sure it needs to be a callback function and not just hard coding the value true or false right here. I may be wrong, but how I got this to work was with a callback, and what we're doing is we're checking to see if this value within our environment variable equals true, and if so, then we're going to return a true value for this parameter, which by default is false. So if this value is not true, then it's going to skip this, and Django will just use the default value of false that was set for that. And so in your environment variable, I'll show you the example environment variable. We're setting that value to true right here. And then just go ahead and make sure that your project is running. So I turned it off and turned it back on right now just to make sure. And then here we could go and navigate back to our home page. And here is where we're going to see the Django debug toolbar. This is the button that I'm hovering over right here to the right. We could go ahead and click on that, and inside expands all of the different tabs that have information provided to you. And so we'll just quickly go through some of these. The hide button will hide it again. You click back into it to open it again. They each have a checkbox here where you can turn these on and off. Then you can click on them to expand into them. Here it will give you the amount of time that it took to, or no, wait, this is the history. This will show a list of every request that was made within this browsers tab within this page. So this page is very, very simple. It doesn't have very much information. The versions tab will then show you a list of packages that are installed in your project, a short name of those projects if that's available, and the version number of them. The time tab is not actually clickable because the only thing that's on it is the amount of time that it took to load the page. Then we can go to our settings. And here this is going to give you a breakdown of all the settings that are defined within your project. And what this means is all of the variables that are found in your settings.py file. And a combination of many different settings.py files if you have more than one of them. For example, third-party apps may have their own settings.py file, and so this gives you a clear defined view of all of them that are defined and what their values are. So if it's even a callable, well, now you could see, well, what is the value in this particular instance. And then the headers is just what it sounds. It's the headers of your document. So this will give you a breakdown of all that information that's available to you. The same as request, which will give you even more information. And here you can find your cookies too. And then the SQL tab is probably my most used tab. This will allow you to view a breakdown of all of the different queries that are going on. So it appears I might be logged into the admin panel. Yes. So I'm already logged into the admin panel, and that is why I was getting this query right here, because Django on the back end is executing a session. So that's why even just for a simple home page, I have two different queries being executed. And then it tells you the amount of time that it took, and you could click these buttons to view an even more of a breakdown of that query. And so also, if you wanted to try to trace what files are involved in performing that query, this would definitely help you do that. And static files, this is a compilation of all of the static files that are accessed on this page. And so for this particular one, it's just the home page image. And then it provides you with all the different apps that have static files. And I believe this is a breakdown of a compilation of all of those files that can possibly exist. your templates. This refers to the actual Django template language. So any of our template files, such as, so we have our static folder, so anything that's inside of our templates folder. This will give you a breakdown of what those files are that are being used. And this breaks them up into the different files right here. I'm sorry, this breaks them up into the different context processors. This section is where if we had more than one template file, it would appear in a list similar to these context processors. This one, however, is only using the one. So if we click the toggle button, we can open it up to also view any of the context that is available to this particular HTML file. And if you had more, you would see a breakdown of, okay, well, this context only is accessible in this HTML file. It's not like it's global context or anything like that. So it really does help you to debug whether or not you have data available to you when you're expecting data to be available. Our cache is not actually being used, but if you had a caching system enabled, this would give you a lot of information about what was being cached on this particular page or request. Signals. These are also an advanced topic that aren't really discussed much in this book. They're similar to a WebSocket, but there are some differences. And then this particular tab will give you information about any of the signals that are operating on this page. In this particular instance, we have a few of them, but these are the built-in ones. I didn't add anything fancy. And then messages. This would relate to our Django messages framework. This would give you a breakdown of any of the logs that are taking place, if they do take place. And intercept redirects, this is left unchecked by default, but if you did check this and then refresh the page and say you had a Django form, and when that form was submitted, it executed a redirect, then this intercept redirect option would temporarily pause or interject in that redirect, and it'll show you an intermediary page that displays information about the redirect that's taking place, any other debugging information you would need, and then as soon as you click to proceed, it will take you to the redirected page. And profiling is also disabled by default. But if we did turn that on and then refresh the page, we could see that Django does provide a lightweight CPU profiler. However, if you wanted to get really nitty and gritty, you'd probably install one of your own CPU profilers. But this is a quick and easy way of trying to see some of that information. And that is how to use the Django debug toolbar.